Charge carriers. Welcome to Decreation's Resources. Charge carriers play a very important role in the properties of a material. Now, if you consider a semiconductor, there are two kinds of charge carriers, namely electrons and holes. Now, depending on what the relative number of these charge carriers is, several properties are going to be determined, several parameters will be decided upon that. For example, conductivity, or whether the material is electron dominated or hole dominated, mobility, etc., is all going to be a result of these charge carriers. Now, the carriers need not be static all the time. There would be different causes of motion of charge carriers, and it could be, say, due to electric field when we talk about drift. It could be a difference in the concentrations when we talk about diffusion, etc. Now, carriers can also be described as free charge carriers. When do we call them free? When basically they are freely able to move in the material under the influence of electric field. Now, when we are talking about this freedom, we also need to talk about the bonding, because the bonding will determine how many charge carriers will be available in a solid. Now, what is exactly a bond? So, when we bring atoms together, each atom will want to get a stable state, that we know. Now, when do we say it's a stable state? When the outer shell has 8 electrons. Of course, I mean, don't think of n is equal to 1, because only 2 electrons are sufficient there in order that it gets completely filled. But for rest of the n values. So, if an atom wants to obtain a stable electronic configuration, it has to either lose or gain or share electrons and then form a solid. Now, let's talk about the typical semiconductor, silicon. So, in silicon lattice, we know that each silicon atom is surrounded by 4 other silicon atoms, and each silicon atom has 4 electrons in the outer shell. So, how many more electrons does it require to complete its octet? 4 more. So, it requires 4 more electrons. Now, in order to obtain these 4 electrons, what it does is it shares its 4 valence electrons with 4 of its neighboring atoms. So, a shared electron now will belong to both the neighboring atoms, and this particular electronic bond, which is obtained by sharing of electrons, is called covalent bond. So, in silicon atom, you will see that there is formation of covalent bond with its neighboring atoms, and that is what yields it stability. Even gallium arsenide has covalent bonds. Now, unlike ionic bond, covalent bond is comparatively weaker. So that means if you at room temperature it might be a stable structure, but if you are increasing the temperature, then at higher temperature some of the electrons which are initially in these covalent bonds now get enough energy to break the bond, and they can become free, and then they can be available for conducting. So the current that we talk about, we need to have conducting electrons, and they can be obtained by increasing the temperature. Similarly, there could be other sources. Now, especially when we talk about solar cell, here the sunlight is going to break these bonds so that the electrons will get excited, and there is eventually a light to electricity conversion. So, the role of charge carriers is very, very important in case of semiconductors.